That's beautiful. This has got to be one of the most proud moments of my life, I guarantee you.
As Apollo 17 prepared to depart the moon, astronaut Eugene Cernan gazed upon the Earth from a vantage point only 11 other men have shared. Leaving a final footprint, he spoke captivating words to the world.
America's challenge of today has forged man's destiny of tomorrow. We leave as we came, and God willing, as we shall return, with peace and hope for all mankind.
We wonder when we will return. Robotic probes were the first to touch the moon.
Those first insights showed us that this was a world more fantastic than we could have dared to hope and worthy of further exploration.
8 years after the first man entered space, humanity stepped onto the lunar dust.
It demonstrated we have a future that previously was not imagined.
The scientific endeavors of Apollo continued to unlock the moon's secrets.
The Earth and Moon have a common origin. So when we learn about the Moon, we learn about our history.
The race is now on to return once again.
We're in a very interesting period because everybody wants to go back to the Moon.
We are going to the Moon to build a scientific base there, pushing the bounds of technology and what's possible.
Our fascination with the moon dates back to time immemorial.
The moon is that perfect distance, so close you can almost touch and be inspired to travel, but so far you got to work real hard to do it.
Earth's companion, long before life existed on our planet.
And you could look up and always see it and always know it's there. So it's always been this fascination of wonder and awe and looking at, and I guess wanting to reach out.
Scientists hypothesize that our moon formed over 4.5 billion years ago, the product of a collision with the protoplanet Theia.
Theia is thought to have hit the Earth and caused the outer layers of the Earth to be shed to form a cloud of debris, which eventually coalesced into the moon.
Over time, our natural satellites settled into orbit, a single side frozen in view, beckoning. Humanity's lunar dream came into focus after the Soviets launched the first Earth-orbiting satellite in 1957. The USSR followed the achievement, placing the first human in space 4 years later.
If you put yourself back in those times, thinking about the incremental steps, okay, we've put somebody in orbit. What's next? Well, let's send somebody to the moon.
The moon became the ultimate prize in the race to dominate space between the US and USSR. Robotic probes would venture first, paving the path for humans. The Soviets' early successes were led by Sergei Korolev, who was known in the West only as the chief designer. Reaching Earth's orbit was one thing, but escaping it would be an even greater challenge.
To simply break the bonds of Earth's gravity is an incredible technical challenge. There needed to be huge developments to get off the surface of the Earth.
In 1959, the USSR prepared the first robotic emissary to the moon, Mekta, also known as Luna 1.
The Earth is a very, very large, heavy object, and therefore to escape its gravitational pull requires a lot of energy.
The first object to escape Earth's orbit, Luna 1 needed to exceed a speed of 11.2 kilometers per second, 33 times the speed of sound. Luna 1 missed its target by nearly 6,000 kilometers. However, there was a silver lining. The probe continued its journey, eventually becoming the first spacecraft to directly orbit the Sun. America's first step toward the Moon began with the Pioneer program, a fleet of probes built to explore the solar system. Pioneer 4 was the first to successfully launch in March 1959.
Midnight is to be the witching hour, and it's a tense and dramatic scene as the rocket is fueled for its fantastic flight.
Unfortunately, its second stage rocket overperformed, and Pioneer 4 met the same fate as Luna 1, becoming the first US spacecraft in solar orbit. The Soviets successfully reached the Moon before the end of the decade, but it wasn't a soft landing. The debris of Luna 2 was strewn across the cratered surface.
Luna 2 was the first object to actually impact the surface of the Moon.
Western observers monitored Lunix 2 radios to the very moment of impact, dead on target.
It was a real engineering feat to get something from the Earth to go 250,000 miles across space and to hit this very small rock.
It carried with it little medallions that were inscribed with the Soviet coat of arms. So while it was a piece of technology meant to demonstrate the USSR's success, it was also meant to implant the Moon with the symbols of communist ideology.
It would be several years before the first controlled landing. The Soviets' Luna 9 was designed to impact the Moon at 22 kilometers per hour, cushioned by a landing bag.
It must have been just an amazing sort of tick-the-box kind of moment to show the world that, yes, we can actually have a controlled descent onto the lunar surface, which is something that's mandatory to land humans there.
Luna 9 commenced its secretive photographic survey on February 3rd, 1966. However, the transmissions were intercepted by the Jodrell Bank Observatory, and an English newspaper was able to publish its pictures to the world.
Now, the vehicle didn't last very long, but it did show the capability of the Soviet Union at the time to be able to get a spacecraft down to the surface and safely.
With the first probe sitting safely on another celestial body, the race was on to explore the Moon in preparation for humans.
Even with the best telescopes on the Earth, we're seeing areas with not very high resolution. We needed to see the smaller scale. We needed to look at the terrain. The scientists wanted to understand where were the places, if we were going to send robots and humans to the Moon, where do you want to actually explore?
Surveyor 1 was fit and ready. It will not be seen again until it sends a picture of itself from the Moon.
The primary goal of NASA's Surveyor program was to demonstrate the feasibility of soft landings on the Moon.
3, 2, 1, we have ignition. We have liftoff.
People didn't know that the lunar soil would be robust enough to support the weight of a spacecraft, even with only 1/6 of the Earth's gravity.
The first of 7 surveyors touched down in the Ocean of Storms on June 2nd, 1966. It was soon transmitting a wealth of data.
The surveyors were essentially designed to look at the environment of the Moon, to measure things like the flux of micrometeorites, these are tiny particles of space dust that impact the Moon, to look at the radiation reaching the Moon from the Sun, to look at the way materials behave when you've got this vast range of temperatures.
The surveyor fleet could only remain planted in place. To explore the entirety of the Moon with enough detail, NASA needed satellites in lunar orbit.
A series of 5 probes were sent up to photograph almost the entire lunar surface, 99% in fact.
Lunar Orbiter was designed to circle the moon with a pair of cameras to photograph large areas of the Apollo landing zone and give good close-up pictures of many possible landing sites.
Using those photographs, engineers and scientists were able to pinpoint the areas that you could land that would give you the best chance of success.
The moon was revealed to be almost fractal in its nature of crater upon crater. The closer we looked, the more hazardous it became. Boulders appeared out of nowhere as you zoomed ever closer. It revealed a world that would be challenging to land on.
Humanity's robotic emigrants revealed more about our natural satellite than ever before. But most importantly, they selected the perfect spot for humanity's first small steps.
Those first insights showed us that this was a world more fantastic than we could have dared to hope and worthy of further exploration.
On September 12, 1962, President John F. Kennedy challenged America to place a man on the moon by the end of the decade.
We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
There were so many hurdles that needed to be traversed in less than 10 years, and there was absolutely no way the US was ready to be able to do that.
NASA initiated the Gemini program in 1962 to serve as a bridge between its fledgling Mercury spaceflight program and the Apollo missions to the moon.
The US approach to getting to the moon was highly orchestrated in steps that were manageable, and without one happening, the other would not happen.
With the induction of 9 new astronauts, Gemini provided America's spacefarers with much-needed experience.
Its goals: test the skills and endurance of the astronauts and practice the rendezvous and docking procedures for the moon voyage.
During Mercury, the astronauts remained inside the spacecraft. Gemini was about tinkering with the different technologies and the different challenges and maneuvers of being in space outside the spacecraft.
Ed White became the first American to venture outside his capsule for 21 minutes, navigating space with a handheld maneuvering unit.
A new term was born, EVA, extravehicular activity.
During the 12th and final mission, Edwin Buzz Aldrin performed 3 spacewalks, totaling 5.5 hours. Gemini also provided NASA's engineers time to design and build the vehicle capable of delivering 3 humans to the moon, the Saturn V.
The Saturn V is a marvel. It is the most staggeringly complex machine that has ever been attempted. The fact that this worked never ceases to amaze me.
To get to the moon, you need a rocket, this rocket, the biggest yet built, Saturn V.
You can't spend months getting to the moon, you have to get there in a few days. So that means you need enough energy to get you fast enough to get to the moon. Now, as you build a big enough rocket, you add more fuel, which adds more weight. That gravity literally holds you back. So you have this battle between weight and speed that you're trying to fight over to get you as fast as possible to the moon.
The Saturn V's development was led by Werner von Braun, a German rocket scientist snatched up by the US government at the end of World War II. Von Braun spent the following decades building upon the rocket technology he had once developed for death and destruction. Behind the Iron Curtain, the Soviet government made plans for a circumlunar mission to take place in 1967. The 50th anniversary of the October Revolution. However, plans came to an abrupt end when the chief designer, Sergei Korolev, passed away. America had to contend with its own major setback in January 1967. 1 month before their scheduled launch, Apollo 1 astronauts Gus Grissom, Roger Chaffee, and Ed White the first American to perform a spacewalk, conducted a series of tests on the capsule's electrical systems.
A number of problems had not been thought of. For example, there were many flammable materials inside the command module, and indeed even in their spacesuits.
And the atmosphere inside was pressurized with pure oxygen. You can breathe pure oxygen, but it's actually a real catalyst for fire and explosives.
Over 3 hours after the men had been sealed inside the capsule, a voltage surge was recorded. 10 seconds later, the crew reported fire.
Hey! Oh, still fire in the close grip!
And so this material suddenly went up in flames. The oxygen fed the fire to absolute inferno, and tragically, the door could not be opened because of the air pressure inside.
The Apollo capsule had been designed with an inward opening hatch. The internal air pressure, exacerbated by the fire, pushed outward, sealing the astronauts inside. All 3 astronauts perished in America's race to the moon.
When you are doing something that visionary, that transformative, that ambitious, it is hard to have 0 casualties in some ways.
Though a terrible tragedy, the Apollo 1 fire became a turning point in the American space program.
It actually galvanized the astronaut corps, it galvanized the engineering teams, the scientists, to get in there, look at the problems, solve them, redesign, rebuild the spacecraft, make it safe for the human travelers.
Vulnerable wires were coated and fire safety measures implemented throughout the cabin.
They then redesigned the door to one where you could exit very quickly in the event of an emergency. They also changed the air mixture inside, so it was no longer pure oxygen, it was a mixture of oxygen and nitrogen.
And less than 18 months after that tragic fire, we were sending the first humans to the moon.
To ensure the safety of their astronauts, the next 3 Apollo launches were uncrewed. Then, in October 1968, humans finally returned to low Earth orbit, with Apollo 1's backup crew taking their place in the history books.
Liftoff of the 1,300,000 pound vehicle was perfect. The first manned flight of Apollo commenced what was to become known as a textbook flight.
Apollo 7 was the first crewed mission of the Apollo program. So it was really important to make sure that the living environments were habitable, that they were safe for 3 astronauts to spend more than a week living there together.
On board, command pilot Schirra and pilots Cunningham and Isley demonstrated that men could live and work in space with increased comfort and efficiency.
Apollo 7 also demonstrated that the command module could safely re-enter the atmosphere,
which is one of the most dangerous parts of such a mission. So it was a real stepping stone to the moon.
The flight of Apollo 7 lasted 10 days and added immeasurably to the confidence level of our space program.
Meanwhile, in the USSR, the lunar dream was getting closer. In September 1968, they sent the very first animals, including 2 tortoises, around the moon aboard Zond 5. After 1 week traversing the heavens, they returned safely to Earth. The Soviets had bridged the Gulf to the moon. Now the Americans would cross aboard Apollo 8.
Apollo 8 was the most important human space mission. 11 was easy compared to 8.
This mission plan was to circle the far side of the moon, enter orbit around our satellite, and return. After a full Earth orbit, the 3rd stage of the Saturn V reignited, setting a course for the moon. 2 days later, Apollo 8's crew became the first humans to reach a distance where the Earth no longer held the strongest gravitational pull. But in order to be captured by the moon's gravity, their trajectory needed to be perfect.
Meters off, you just sailed out into the emptiness of space and they would have never had a way of coming home.
The capsule slowed into lunar orbit.
Once you go around the moon, the far side, you cannot communicate with Earth. The moon is literally blocking you. So if something goes wrong, you are literally alone in the void of space.
Mission Control would have to wait 32 agonizing minutes for Apollo 8 to reappear.
There was a lot of things that could have gone wrong. People would have been seeing these astronauts sail away into space, slowly dying. It would have killed human space exploration.
Not only did Apollo 8 successfully circumnavigate the moon, it did so 10 times.
The mission of Apollo 8 was a really bold move by the United States.
There were first human beings from the planet Earth visiting another world. They became satellites of the moon.
It gave human beings the very first glimpse of the Earth rising above the surface of the moon.
All right, you're looking at yourselves as seen from 180,000 miles out in space.
Seeing our little fragile blue marble in the vast darkness of space was the catalyst for the modern environmental movement.
It was a beautiful experience, I think, for all of humanity.
Apollo 8 demonstrated that the US could successfully deliver humans into lunar orbit. But a dress rehearsal was required before the first footprint. During Apollo 10, 2 astronauts boarded the lunar lander and practiced the descent towards the moon's surface, but they weren't allowed to land.
Now, there was speculation at the time that they wanted to make sure the astronauts weren't tempted to land on the surface of the moon. So the story, which is in some ways urban myth and some areas true, is that they didn't give them enough fuel on board the spacecraft, so they weren't tempted to make that final part of the descent.
The fact that NASA didn't give Apollo 10 enough fuel to actually land and then safely take off suggests that they were aware of the allure of that first landing. Astronauts are near superhuman, but they're still human, so they might have been tempted. Those kind of missions paved the way for Apollo 11.
Meanwhile, the USSR was modifying their counterpart to the Saturn V to deliver humans to the moon. But on July 3rd, 1969, an explosion destroyed the rocket's launch pad. Soviet lunar exploration was relegated to their fleet of probes. For the US, the day was approaching. Years of technical development, engineering breakthroughs, and rigorous training, all built to a single moment. On July 16th, Neil Armstrong, Buzz Aldrin, and Michael Collins boarded Apollo 11. Breaking free from the Saturn V, the Command Module Columbia and Lunar Module Eagle continued toward the moon.
Once the Apollo crews reached orbit around the moon, they then had the final challenge of getting onto the moon's surface.
While Collins remained in orbit aboard Columbia, the Eagle descended to the moon.
Control is good. Roger, copy.
The astronauts were using an automated system on board. The onboard radar was ticking off the descent rate.
Until the computer started spewing out all these error messages.
Reading on the 1202 program alarm.
Those computers were actually heading the spacecraft towards a large boulder field. So Armstrong took over the controls. He had to fire the engines for longer periods of time. Fuel was starting to be used up at a much higher rate than had been predicted.
60 seconds.
You can hear Houston Mission Control counting out how many seconds of fuel they've got left.
30 seconds forward.
It came down to actually the last 16 seconds of fuel left.
Tranquility Base here. The Eagle has landed.
Roger, Tranquility. We copy you on the ground. You got a bunch of guys about to turn blue. We're breathing again. Thanks a lot.
The astronauts were supposed to have a rest when they landed on the moon, but they really rebelled against that. They wanted to get out there. They wanted to get going.
Just 12 years after humanity breached the heavens with the first artificial satellite, we placed our feet upon an extraterrestrial world.
That's one small step for man, one giant leap for mankind.
Across the globe, people were able to witness the historic moment.
They set up a television camera, the first thing to be placed on the surface after the landing module. If you think of the most culturally significant object at the Apollo 11 landing site, it's probably that television camera because it recorded the images beamed to approximately 600 million people across the world.
As Armstrong and Aldrin experienced the lunar surface, Collins attended to maintenance aboard Columbia, whilst ensuring it had the proper trajectory for his colleague's return. Continuously circling the moon, he lost contact with all humanity for 47 minutes on each of the 30 orbits.
That is the most isolated feeling that you can possibly have. But at the same time, I've heard that being the support line for colleagues walking on the moon is an incredibly satisfying and incredibly rewarding feeling.
America's mission extended beyond the first small step. Armstrong and Aldrin deployed retroreflectors and other scientific instruments to unlock the moon's secrets.
They wanted to find out, was the moon seismically active? And so they set up seismometers. Back here on Earth, they could even actually measure the footsteps of the astronauts as they bounced past the instrument. They also had to collect geological samples. So these astronauts, these pilots, had to also become scientists. Right at the end of the mission, they were told, you don't have enough rocks collected yet. So there was this frenzied few minutes just before they had to get back in the spacecraft. And astronaut Armstrong actually said, well, we've collected all the samples we can get. They might not be the best samples, but we have them. And we're still studying those rocks today.
As Armstrong and Aldrin completed their 2.5-hour spacewalk, the Soviets' Luna 15 was attempting to land. It had arrived in orbit 2 days earlier, with hopes of returning a soil sample to Earth before the Americans. But the landing had been delayed. As it descended to the surface, the Soviets lost contact forever. The space race was effectively over. Less than a day after the Eagle landed, it was time to depart.
President Kennedy said, we're going to get a man to the surface of the moon and return him safely to the Earth. That was the important part, getting them back home again.
After successfully reuniting with Columbia, the Apollo 11 crew returned to Earth, splashing down in the Pacific Ocean. The USSR never came any closer to sending a citizen to the moon, but they persevered, developing machines for exploration.
Astronauts are good at making decisions and identifying various features and geology, but rovers are also very successful in exploring the moon because they allow us to travel further and to be more interactive with our exploration.
The Soviets' Lunokhod 1 was the first robotic rover to venture beyond Earth. It drove 10.5 kilometers over 321 Earth days, returned over 20,000 images, and performed experiments on 25 soil samples.
Because the moon has no atmosphere, all of the tracks are just laid out there for us to see. They're going to be preserved for possibly millennia.
Lunokhod carried a retroreflector, enabling scientists to measure the moon's distance from Earth. Timing the return of a laser pulse after bouncing off a retroreflector reveals how far it traveled. Along with similar Apollo experiments, these endeavors revealed that the moon is moving further away, on average 3.8 centimeters per year. Having achieved the coveted first step, NASA's later Apollo missions would place increasing focus on scientific endeavors. Apollo 12 carried the baton of an earlier explorer.
An opportunity was taken to put the spacecraft down near Surveyor 3, an earlier robotic mission during the Apollo preparations.
Surveyor 3 had spent 2.5 years on the moon.
Putting up with the huge range of temperatures, the rain of micrometeorites, bombardment of subatomic particles from the sun, and the ultraviolet radiation from the sun, all of that had been withstood for a long period of time.
Pieces of Surveyor 3 were brought back to Earth, where scientists gained insights into the lunar conditions.
What they discovered was that the landing of Apollo 12 at the edge of that crater had stirred up a lot of dust, and this had abraded the surfaces of the Surveyor camera. This is only the second Apollo mission, and what they were coming to learn was that lunar dust was going to be a big problem for surface operations.
The third crewed mission to the moon was 2 days from Earth when disaster struck. Nine minutes after ending a television interview, the crew heard a sharp bang.
One of their oxygen tanks ignited.
Houston, we've had a problem. Had a BP bus undervolt.
The command module lost all electricity, light and water. 2 of the 3 fuel cells were dead. Precious oxygen was leaking into the darkness. With 15 minutes of power remaining, the crew evacuated into the Aquarius lunar module.
The module, which was intended to keep the astronauts alive on the moon for a couple of days, then had to be quickly repurposed to keep them alive on the way and on the way back for, I think, about 4 days. And so it was a mad scramble to get the crew back alive.
While the Aquarius had sufficient oxygen to sustain them, it lacked the ability to purge enough carbon dioxide. On the ground, a team of engineers rushed to design a mechanism out of spare parts that could purge the excess CO2.
And 13 Houston, we'd like you to isolate the repress package, please.
Despite never landing on the moon, the mission was not a complete failure. The third stage of their Saturn rocket was sent crashing to the lunar surface. Calibrating seismic detectors installed by Apollo 12.
Odyssey Houston, we show you on the mains. It really looks great.
The next mission, Apollo 14, successfully landed in the Fra Mauro highlands. It was commanded by Alan Shepard.
Of course, Alan Shepard, the first American to actually go into space, got to walk on the surface of the moon on Apollo 14.
He carried with him a sample collection tool, which had been modified into a 6-iron.
Being the keen golfer, of course, he was a bit disappointed by his first shot, which sliced the ball, and then he took his next shot, steadied himself, he hit that ball. They asked him, "How did it go, Al?" And he said it went for miles and miles and miles.
The mission, however, was not restricted to lunar recreation. The crew discovered Big Bertha, a 4-billion-year-old 9-kilogram rock that likely came from Earth, the first terrestrial meteorite. For the first few missions, astronauts were restricted to local exploration, but both range and ambition increased come Apollo 15.
It was the first real in-depth science mission. And the astronauts had taken the challenge of doing the science very, very seriously.
The tower is clear. And we have a roll program. Roger.
Over 3 7-hour-long spacewalks, astronauts collected samples from 12 different locations, exploring the moon's volcanic history. To facilitate wider discovery, NASA engineered an ingenious transportation system in just 17 months, the Lunar Rover.
To design a rover in such a short amount of time, to have it operate so spectacularly, these are incredible achievements. The fact this thing even managed to make it to the moon alone is stunning, much less that it worked and looked so fun. And sometimes space exploration just has to be fun.
It's working, my friend. Beautiful.
They could go off on these longer journeys day after day, moving further afield, collecting geological samples from diverse regions.
The Apollo 15 astronauts traversed 12.5 kilometers in a single spacewalk.
And so the Lunar Rover really changed that ability to do that thing that we love to do, and that's explore.
The next mission, Apollo 16, touched down in the central lunar highlands, set apart from preceding landing sites. For years, scientists had believed that the region was a product of ancient volcanism. But nearly every rock Apollo 16 collected had not formed from volcanic activity. The supposed history of our moon continued to evolve. The geological discoveries continued, with greater focus during Apollo 17.
One of the crew was a geologist. For the first time, a scientist went up as a crew member.
Harrison Schmitt discovered tangible evidence that our moon once sustained a magnetic field.
He was able to bring back to Earth material and evidence for the geology community to really make some quite transformational discoveries about the moon's origin.
And he was traveling with Captain Gene Cernan, who was a military pilot. So they had very different backgrounds, very different experiences. But I remember Gene Cernan telling me that, in fact, he was a little bit converted as a geologist and found the rocks and the collection of rocks very exciting.
It turns out that that mission brought back more scientifically relevant material than the whole Apollo program itself.
Holy smoly! Why are we on a slope? You okay?
Man, that's rough country in there, isn't it?
After more than 3 days on the surface, it was time to depart.
We leave as we came, and God willing, as we shall return, with peace and a hope for all mankind.
Apollo 17 returned to Earth, setting several records. The longest time humans spent on the moon, the longest extravehicular activity upon its surface, and the longest time in orbit. With waning political support and budget cuts, Apollo's future missions were cancelled.
It was such a huge investment. The public support for continuing that or expanding it was kind of dying down a little bit in the 70s.
Nonetheless, the Apollo program transformed our understanding of Earth's natural satellite.
I think some of the biggest success of the Apollo missions wasn't the human aspect. Yes, it was important, but they did so much for our understanding that we literally use today. If Apollo did not land on the moon, and leave little metal reflector plates that we can bounce lasers off of back to the Earth, GPS doesn't happen the way it does.
The moon is part of our history because the Earth and moon probably have a common origin. So when we learn about the moon, we learn about our history here on planet Earth.
All these little scientific reasons were just an add-on to this human exploration. And that is, I think, the amazing feat of the Apollos, what it did for knowledge and not just inspiration.
It would take more than a race into the history books for humanity to return to the moon.
At least from the public's point of view, exploration for the sake of exploration was not sufficient. You had to have a mission that was not just about being first, but about something more. And this is where the robotic era begins.
14 years after the last lunar probe, Japan prepared to become the third nation to send a robotic traveler. Hiton was designed to test technology and orbital maneuvers for future exploration of the solar system. The Japanese probe was later steered into a temporary lunar orbit, where it measured cosmic dust. Within a decade, the moon had regained its status as the next frontier. A new kind of international competition was born.
There are now many nations which are sort of at the beginnings of their space program. They're setting their sights on the moon as well.
It's about understanding what resources are there and perhaps being first to utilize those resources.
The European Space Agency's Smart 1 satellite was inserted into lunar orbit in 2004. Like Hiton, it demonstrated cutting-edge deep space technology. Employing a new propulsion system, Smart 1's ion thruster ejected subatomic particles, accelerating the spacecraft forward. In lunar orbit for 2 years, Smart 1's instruments mapped the surface, identifying the composition and distribution of minerals. Pushing the frontiers of lunar exploration further, China designed Yutu-2, the first rover to roam the moon's far side. On December 7th, 2018, China launched Yutu aboard Chang'e 4.
And it's returning incredible science, going to places which are incredibly different from what we saw on the near side during the Apollo program.
Chang'e 4 delivered Yutu to the Aitken Basin,
which is actually one of the biggest impact basins in the whole solar system, a place where something very large hit the moon early in its history, probably within the first 10 million years of the moon's lifetime. Some of the rocks that have been found by Yutu-2 are actually a bit of a mystery because some of them seem to be quite young, much younger than you would expect to find in a place where an ancient impact had scattered the debris around.
Meanwhile, the US has been keeping a close eye on the moon from orbit since 2009.
Liftoff of the Atlas V rocket with LRO Albatross, America's first step in a lasting return to the moon.
A lot of the exploration of the moon that we're doing nowadays is actually from lunar orbit. We have very high resolution cameras. The moon has no atmosphere, no clouds. So we can actually really study it very well from orbit using radar, using infrared technology, and using high resolution images.
The moon's longest operating companion, the Lunar Reconnaissance Orbiter, has collected more data than every extraterrestrial NASA mission combined. High-resolution maps identify points of interest for future missions.
We have returned to the moon, and the boundaries of humanity's exploration explode when we decide to entrust exploration to robotic pioneers.
Launching in 2008, India's first lunar orbiter, Chandrayaan-1, carried 2 instruments based on Smart 1's design. The mission proved that the moon was once completely molten and found the first evidence of water ice.
The moon is a very dry place, but we do find water in very deep craters in shadows, and we also find it towards the poles where it's cooler. So the moon does have water, but it's really in icy form and it's hiding away.
The discovery of water on and near the lunar surface carries great implications for humanity's future beyond Earth.
Water on the moon has changed the calculations for countries and companies alike. This game-changing discovery of these ice reserves has only really happened because of this robotic era of exploration.
The moon is no longer a destination for just governments. Private industry seeks to see footprints in lunar soil once again.
We're in a very interesting period because everybody wants to go back to the moon.
The new era of lunar exploration is to map out the water.
For humans to be able to go to the moon on a frequent, reliable, sustainable way, access to water in situ is really important. Of course, we can take water with us. We do that to the space station. But the cost of doing that is huge.
The moon will serve as a gateway to the solar system.
So that water ice can be used to make fuel. It can be used to sustain bases that might be built on the moon for permanent occupation. And in the minds of a lot of people, this water ice can be used to make fuel to take people on to Mars.
The moon becomes not just a stepping stone, it becomes a refueling and resupply station. And that has attracted the attention of nations and even companies.
National agencies and private industry have supported each other in development. From lunar landers to the rockets that will carry them.
We currently have a number of companies out there, commercial operators, with large, heavy launch vehicles.
We should really do our very best to become a multi-planet species, to extend consciousness beyond Earth, and we should do it now.
SpaceX has influenced spaceflight in an extraordinary way. In the old days, you threw away the launch vehicle because there was no way of salvaging it. But with the technology we have today, you can actually bring the launch vehicle back.
In addition to their current role, ferrying supplies to the International Space Station, SpaceX plans to return humans to the moon within the decade.
It's a really exciting time, actually, that we're going back there. People like myself don't remember the moon landings. As we enter this new dawn of going to the moon and eventually to Mars, I'm hoping we're going to get those moments again.
Bearing the name Artemis, the twin sister of Apollo, NASA's new human spaceflight program also has its sights set upon the moon. The Orion capsule is designed to fit on top of the replacement for the Saturn V, the Space Launch System.
In the same way as Apollo had its stages of increasing sophistication of the mission, Artemis will see this return to the moon and then beyond. It is a staged approach of getting ultimately to Mars.
And liftoff at dawn, the dawn of Orion.
Orion blasted off for her maiden test flight in 2014, reaching an altitude of 5,800 kilometers and orbiting the Earth for about 4.5 hours. A lunar colony may soon be on the horizon, be it as a permanent workstation or as a stepping stone to further worlds.
One of the aims of going back to the moon is to build some kind of permanent installation or base there for scientific investigation. But for many people, the whole purpose of going back to the moon is to mine all of the water ice at the poles, to use it for fuel, and make the journey to Mars just that bit shorter and safer.
It's going to be incredibly challenging to establish a human presence on the moon. It's a really bad environment to live in. There's no air, there's no magnetic field, which helps protect us from the dangerous radiation from space. It's close to the Earth so we can deliver stuff, but keeping astronauts safe from meteorites and radiation and all those sorts of things is going to be very difficult.
The moon symbolises a number of things. In the same way the International Space Station brought many nations together, we are going to the moon to continue to learn about that cooperation, to build a scientific base there. All of these sorts of things are an example of the way that we can live and work better together on our own planet and harness the resources that space could bring and the benefits that come from doing that exploration, pushing the bounds of technology and what's possible.
The lunar dream has long been calling.
As a species, humans are absolutely fascinated by the unknown. Nowhere represents the unknown more than outer space.
Exploring Earth's companion, we understand our past, our planet, ourselves.
It's kind of in here. It's kind of human curiosity and human spirit.
Humanity's lunar achievements are just the first steps.
We're just doing what we've always done. These will take us off on journeys to Mars, to the moons of Jupiter and Saturn, and then even one day to the nearest stars.